Hello, mathematicians. Welcome to Geometry, 4th grade. This is session 4, day 4 of lesson 30. It's all about parallel and perpendicular lines. We've been working the geometry and having a blast, so welcome, glad you're here. Which shape has parallel sides? The square or the right triangle? You are correct. Parallel sides. So we've got two pairs of parallel sides. There's one pair of sides and another pair of sides. All right. This right here is not parallel. This meets at a 90-degree angle, which makes that part perpendicular. Okay, remember the symbol for parallel is just the two lines like that. Always fun to do. All right, make sense of this problem. Jordan looks at the street map below. We got Oak Street, First Street, and Ash Street. Describe the relationship between Oak Street and First Street. Then describe the relationship between Oak Street and Ash Street. So what is this problem about? Streets. Got 3 different streets and we're looking at their relationship. That's what it's about. Don't like that color. Okay. Number next, read. What are we trying to find out? Jordan looks at the street map below. Describe the relationship between Oak Street and First Street. So we're trying to find relationship and describe the relationship, okay, between those two and those two. That's what we're trying to find out. Third, read. What information is important? Third, read. Jordan looks at the street map below. Okay, so it looks like it's important that Oak goes this way, First goes this way, and Ash goes that way. Looks like it's important which way they go. Describe the relationship between Oak Street and First Street. And then the relationship between Oak Street and Ash Street. Okay. All right. Next slide, we get to give it a go. Solve and support. Geoboard, straws, tracing paper, grid paper, whatever you have. I mostly have these tools right here. And this. All right. So I'm trying to find the relationship between a couple different streets. We'll start with Oak and First. Oak and First. Well, if I was on Oak Street and First Street, I would not say that they cross each other, right? They go like this. Yep, I agree. So it looks like if I draw this line out and I draw this line out as one, tool using color, because that's fun, the relationship between those two is this symbol or the word parallel. You could use the word, you could use the symbol, but they go parallel to each other. All right, and then for the next one, Oak and Ash. So now we're looking at this connection, Oak and Ash. They do cross. So if you go on Oak Street and Ash Street, you will cross either one of those. And how do they cross? They cross in this lovely 90-degree, which means they are perpendicular. So the relationship between those two is this symbol, which means perpendicular. So you could write out this big long word and you would be correct. Or you could put the symbol and you would be correct. All right, nicely done, mathematicians. Ask your partner, why did you choose that strategy? At first I thought I'd use the strategy of color and drawing. Because at first I thought it'd be easy to see. And it was. When you have the color there, you can easily see the visual relationship between the streets. Compare class strategies. So how might other people do this? They might pull this out of the diagram. They might say, okay, Oak and First. So you could pull the picture out. That could be a strategy. And then you could have Oak and Ash and then label. I think that could be a different strategy. What did you do? Anything different? Those are the 2 strategies I can think of. Color and then pulling that out. So let's see what the Ready Math says for us. Sketch a picture. Yes, very nice. I like that one because that's the color option. Shading the streets. Super fun. All right, I'm good with that. And we notice that they do not cross. You can use a model to help you understand. Okay, I didn't do this one. Look at Oak Street and Ash Street. Think of each street when two lines cross, they form four angles. Okay, so kind of when I said you could pull it out, and then I was thinking you could put like four right angles, is what I was thinking, but they labeled them 1, 2, 3, 4. Okay. Making connections. Lines that are always the same distance apart and never ever cross are called parallel lines. Name a real world example of parallel lines. Yep, the ever famous railroad tracks. We use that all the time because it's a great example and it works. There are more. Suppose each street keeps going in a straight line. If Jordan travels on Oak Street and makes no turns, can he ever get on first? He travels on Oak and makes no turns. Travels on Oak and makes no turns. Okay, kind of need to see the picture. If he travels on Oak, can he get to first? Dun, dun, dun. Traveling on Oak, can he get to first? No, it's parallel. Yeah, so you were right. Those of you who said no right away, you were right. No. Because the roads are parallel. No. If he needs to make a turn if he wants to get on that street. Describe the angles that Oak Street and Ash Street make when they cross. Oak and Ash. Is that the ones that go perpendicular? Yeah. Oak and Ash. So describing that angle, yeah. That one you knew. They make a 90-degree angle or a right angle. What do they call it? A right angle? 90-degree? Yes. Lines that cross and form at a right angle dun, 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 are called perpendicular lines. Name a real world example. Well, what would you say? What in the real world has perpendicular lines? Well, we've got the intersections. Other times window panes, right? Apparently that goes right in there. A window pane can have perpendicular lines. Lots of places. Okay. Add your examples for perpendicular lines. Explain why three separate lines can all be parallel to each other but cannot all be perpendicular to each other. Okay, so if you have three lines, boom, 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 they can easily be parallel, yes, but they cannot be perpendicular. Yeah, if you're parallel, you can't be perpendicular. You couldn't be perpendicular to this one, and that one could be perpendicular. But if I make another one perpendicular, that doesn't work. 1, 2, yeah. So these three lines, you got some perpendicular, some parallel. So 3 lines can be parallel to each other, but cannot all be perpendicular. So you can make 3 lines be parallel, but you can't make them all be perpendicular, not to each other. To another line, you could. Interesting. Look back at your try it strategies by classmates and picture it and model it. Which models or strategies do you like the best for identifying parallel and perpendicular? What do you like the best? So we had a model. We had a sketch and color. We had the pulling it out kind of strategy, which is kind of like a model, pulling it from that. Well, I'm going to go with my usual go-to. You decide what works for you. I like color and label. Color just really helps you see it. Nice to have that explained. Okay, that's why. It helps you see the relationship. Yeah, if we're looking at two pink lines going across, you can see they're parallel. And it just makes it easier to kind of visually see it. Visual mathematics is super helpful. Next, on page 664, how many pairs of parallel sides does the shape have below? This is the same shape we had yesterday. The trapezoid, it's back. 4 sides, 4 angles. Way cool. But how many parallels? Well, let's use the color strategy, because why not? What color do I have? There we go. Because it looks like I think we see 1 pair of parallel. So how many pairs? 1 pair, right? We need 2 sides to make a parallel, so 1 pair. Because these ones over here, I'll do in a different color for our non-example. These are going to eventually cross, so they keep going, right? Not parallel, right there. 1 pair of parallel on the trapezoid. That's what makes it a trapezoid. That's annoying. How many pairs of parallel sides does the shape below have? How many pairs of parallel sides? I believe we've done this before too. So we've got 1 pair, and then using my color strategy, make it look Seahawks colors, 2 pair of parallel sides. How do we know? Because there's our proof right there, right? The proof is in the coloring. How do we know? We got 2 green and we've got 2 blue for 2 pairs. That's how we know. Sometimes people get stuck because they say there's 4 parallel. Parallel comes in pairs. Which pair of lines are perpendicular? That's obviously parallel. This one's parallel. These are parallel. This one, they cross, but they have to cross at a 90 degree. So, no. This one, does it cross at 90? Yes, it does. I agree. Letter C for number 9 on our exit ticket. Okay, so that ends on page 664. Do we have another thing? We do not. So you get to do probably, let's see. Yep, you get to do page 665 and 666 on your own. Excellent work, mathematicians. Nice job with parallel and perpendicular. See you next time. Bye.